Hi everyone, today we're going to be having a look at hyperbola graphs as well as truncus graphs. Now these are graphs that are in the form 1 on x or 1 on x squared, and due to the x being on the denominator of the fraction, it ends up changing the shape of this graph quite a bit. There are some key things that you really need to note when it comes to these graphs. Now we're going to start with just filling in these table of values here, and what you'll see is that you've got very small values to begin with, and then you get to 0. Now if I have 0 on the denominator of a fraction, it's undefined, so there's going to be points on this graph that we can't sketch, which we've come across in our tangent graphs before as well. Going the other way, these values kind of mirror themselves just on the other side of the y-axis, okay? So when we sketch these, I'm going to plot these points out, and what you'll notice is they have a bit of a curve to them. And if I was to go here, it would end up looking like this. It kind of rebounds up like that, okay? Now, I've just drawn that on the complete wrong side, don't mind me. But if I was to draw that out correctly, it would look like this. And then on the other side, it would end up looking a bit like this. So they kind of mirror themselves. So a hyperbola will mirror itself along the line y equals x. Now, like I mentioned before, we have those points that are undefined. With a regular hyperbola that hasn't been transformed at all, you're going to have two asymptotes. So remember, an asymptote is just a line that the graph approaches, but it can't touch it. It never reaches it. Okay, so these graphs will keep on going up towards infinity or down towards negative infinity and never hit this asymptote. And for an untransformed graph, we've got an asymptote at x equals 0 because the bottom of the fraction can't be 0. And then as a result, our y asymptote happens at y equals 0 because there's no way to make the fraction 1 on x 0. Okay? If we did the same thing for the truncus now, looking at 1 on x squared, what you're going to notice is that all your values are positive. So we're going to be above the x-axis, and we're still going to end up with that undefined point at 0, okay? So our graph's going to look slightly different here, but we end up with the same sort of shape just on the other side, okay? Now, all this means is that this gets mirrored in the y-axis instead of that line y equals x. We've still got that key point here at 1, 1 and negative 1, 1, whereas with our truncus, it happened at 1, 1 and negative 1, negative 1, okay? Our asymptotes for this untransformed graph are still going to happen at y equals 0 and x equals 0 because our graph cannot touch that point, okay? And what you'll see is that this changes the way that we're going to write this domain, remembering how we use things like real numbers, but including numbers or not including numbers like 0. So for a rectangular hyperbola, if we were to look at the domain on this graph here, we can see that we're using every x value except for 0. So remember, to write that, we're going to say it's an element of real numbers, just not 0. Okay? And then same for our y values. We can see that we've got all our real numbers except for 0. Now, as x tries to approach 0 from that left-hand side, we can see that y tries to approach negative infinity, right? Whereas if we came from the right-hand side, we see the graph just keeps on going up. As y kind of comes down and approaches 0, we can see that x begins to approach infinity. So they never end, and these graphs will keep going and going and going unless we restrict that domain. Now, like I said before, we've got that horizontal asymptote at y equals 0 and our vertical at x equals 0. And then our asymptotes are going to intercept at 0, 0. Okay? Same sort of thing for the truncus graph, except our domain, sorry, not our domain, but our range is going to look a little bit different. Now, as I said before, our domain is going to be all real numbers except for 0. But what we can see is our y values are all above the x-axis. So we can say that our y is just all our positive real numbers, okay? And as x approaches 0, y is going to keep going towards infinity. Now, our asymptotes are in the same spot with y equals 0 and x equals 0, intersecting at 0, 0. Okay, now for the hyperbola, some key points to note are going to be your 1, 1 and your -1, -1. And then similarly for your truncus, we pass through those points 1, 1 and -1, 1. Okay, so for an untransformed graph, those are your turning points. Okay, now when it comes to sketching truncuses and hyperbolas, the main key things to note are things like your asymptotes and that turning point if you've figured out how it moves. Okay, now as with every graph, we can have some transformations that occur, things like dilations and reflections, as well as translations. Now for this one here, if we're looking at y equals 2 over x, our a is 2, and that's a dilation of factor 2 from the x-axis, okay? Which what you'll notice for a hyperbola and truncus doesn't really do a lot considering they're already going towards infinity. Now, because we're dilating 2 from the x-axis, this point here is going to double. So 1, 2 is going to become one of my new key points, and that 2 half is going to become 2, 1. Okay, so all those values are doubling. Same thing on this end here, is it hasn't been reflected, it's just been stretched a bit. Okay, so these are the new points we're working with, and then it's a matter of just connecting the dots. Okay, making sure that we never hit 0 for this one here. And then same idea on this end, remembering we still have our asymptotes at x equals 0 and y equals 0. Okay, so our domain is still all values except for 0, and our range is also all our values except for 0. Okay, our asymptotes are still going to intercept at 0, 0. Okay, so dilating doesn't affect your asymptotes, it just affects how fast your graph climbs. Okay, same thing here, I've got a dilation of factor 3 this time, so we're tripling those values away from the x-axis. All right, so that means that that 1, 1 becomes a 1, 3. All right, same with if I looked at that 3, 1, 9, that's going to become 3, 1, 3 instead. Okay, so those values are dilating away. And then on the left-hand side, because this is the truncus we're looking at, these are going to reflect just in the y-axis instead. Okay, then we're going to try to sketch that as best we can, and label those 2 points that we found. Try to make yours a little bit less wonky than mine. Okay. With 3 and 1/3. All right, our domain, same sort of thing, is going to be all values except for 0, and our range is going to be all positive values, okay, with our asymptotes still being in these same spots. All right, and they're still intersecting at 0, 0. Now, if we have an a value that is less than 0, we're going to be reflecting the graph in the x-axis. Okay, so it's going to get flipped upside down. What that's going to mean for the truncus graph here is that it's going to actually look like we've reflected it in the y-axis as well, but we've really only reflected it in the x-axis. Okay, so here I've got just a reflection in x, so this -1, -1 becomes -1, 1 instead, and this 1, 1 here is going to become 1, -1. Okay, so it's just flipping those y values due to that reflection in the x-axis. Okay, so our domain is still going to be the same, even though we've reflected it, and our range in this case is also going to be the same, with our asymptotes intercepting at 0, 0 and being labelled as well. Okay, don't forget to label your asymptotes, especially later on when we move them. Same thing for this truncus here, is we're going to reflect this in the x-axis, which means that these points are going to move onto this side here, And we're going to end up with that tree trunk looking picture, but reflected instead, kind of like a mirror, okay? So that's going to be 1, -1 for that coordinate, and -1, -1 for this coordinate, with our domain and range still being the same, as we haven't moved those asymptotes at all. Now, in this case for our y, though, it's going to end up being all negative values of the real numbers, with our asymptotes intercepting at 0, 0, okay? Now, another thing that we can apply to truncus and hyperbolic graphs is a translation. Okay, now the translation does the same thing in these as it does in things like your quadratics, with h translating your x and y translating your y. So our asymptotes are going to occur at x equals h, because we cannot have the denominator equal to 0. And then our y is going to occur at y equals k, because we can't make that whole fraction equal 0. Okay, so for this example here, we're just moving 2 units in the positive x direction, and this is where it becomes really important to label your asymptotes, because our asymptote here is going to be at x equals 2, and our other asymptote is going to stay at y equals 0. Okay, now everything's been moved 2 to the right, so that means that our graph here is going to end up essentially looking the same, but just with that turning point moved over. Okay, so it's going to be 1, -1, and this will become 3, 1. Okay, our domain now, instead of all numbers except for 0, is going to be all numbers except for the number 2. And our range is still going to just be all numbers except for 0, okay? This time our asymptotes are intercepting at 2, 0. Now, same idea here for this truncus. We can see that we haven't moved in the x direction at all, but we have moved 3 units in the negative y direction. So that means that our asymptote is going to be moving 3 units down. Okay, so drawing this out, moving this 3 units down, and now my whole graph is going to shift 3 units down, and it's going to end up looking the same, except that it has quite literally just been shifted 3 units down. Okay, so this now becomes 1, -2, and this becomes -1, -2. Now, our domain in this case, we can see we've got all x values except for 0, but our range this time, we can see we're above that line of y equals -2. So that means in this case that our range is going to be y going from -2 not included to infinity also not included. Okay, oh sorry, -3. That means that our asymptote's intercepting at 0, -3. Okay, feel free to pause the video here, and then I'll pop the answers up as well. For this one here, I can see that we're moving 2 units in the positive x direction, and we're moving 4 units in the negative y direction. Okay, that means that our asymptote's going to be at 2, so x equals 2, and y equals -4. Okay, because no dilations or anything have been done to this one, that means that we just end up moving the whole graph 2 to the right and 4 down. So we're going to have 1 occur here and 1 turning point occur here. Okay, and you just end up with a bit of a long tail up here. Hopefully yours are a little bit smoother than mine when you sketched it. But now we have a turning point at 3, -3, and another one at 1, -5. Now our domain is everything except for the number 2. And our range is everything except for -4, with our asymptotes intercepting at 2, -4. Okay. Same thing here. We've got 1 unit in the negative x direction, and we've got 2 units in positive y direction. Okay, so our asymptotes now are going to be at x equals -1 and at y equals 2. Okay, that means our whole graph as well has just been moved 1 to the left and 2 up as well. So this time we're going to end up with a y-intercept that we can label just at 0, 3. And this point here is -2, 3. Now our domain is once again going to be everything except for -1 this time. And our range is going to be from 2 to infinity, not including either of those, with our asymptotes intersecting at -1, 2.